Okay, so we just want to kind of keep making some connections here between our derivatives. And so we've talked about what we know about the function given the first derivative and the function given the second derivative. Now we want to kind of compare f prime to f double prime. So it says, since the second derivative is the first derivative of f prime of x, the same relationships that exist between f of x and f prime of x must exist between f prime and f double prime. And that's kind of hard to think about sometimes, but if this is the second derivative, it's like the first derivative of the first derivative. And so let me kind of talk you through this and see if we can make any sense of it, and then see if we can look at a graph. So if the second derivative is equal to 0 or undefined, remember what that tells us about the original function. That is a possible inflection point, right? We still have to check, right? So if you don't want to write pip, remember that it's a possible point of inflection where the graph changes concavity. But what does it tell me about where's that going to be on the derivative? Well, on the original function, when the derivative is equal to 0 or undefined, what does that mean? Well, it's a max or a min. And so that's the same thing. If the second derivative is equal to 0 or undefined, that's a possible relative max or min on my first derivative. What do I know about if the second derivative is greater than 0? Well, in the original function, if the second derivative is greater than 0, remember that means that the graph is concave up. And I'll even go ahead and say if it's less than 0, remember that that's concave down. But what about from the first derivative to the second derivative? If this is like the original function, and I take its derivative and it's greater than 0, remember that means the function is increasing. And so the same rules that apply are going to connect f prime to f double prime. So this means that the first derivative is increasing when the second derivative is positive, and that it is decreasing when the second derivative is negative. What do I know about the function if the second derivative changes from positive to negative or negative to positive? On both of those, remember that is how you prove that your graph has an inflection point, because it changes concavity. But on the first derivative, if the second derivative changes from positive to negative, that means it's changing from increasing to decreasing. That means that there's a relative max. And if the second derivative changes from negative to positive on the first derivative, negative to positive would mean a relative min. And so we're really going to work on this the next couple days of trying to get these connections made. So if you have your calculator, I want you to graph this, and if not, I'm going to pull it up here. But it says, consider the function h prime of x equals 2x minus x sine of 2x. So this is already the first derivative, right? We want to graph that from -5 to 5 and answer the following questions. And so I'm going to pull this up. That's not the right thing. I graphed this. I'm going to go to my window, and I'm going to change it from -5 to 5. I'm not really sure what the y should be, so I'm going to graph it. And if I can't see everything, then I'll change it again. Oh, look at that interesting graph. I kind of wish I could see this bottom number, and we'll zoom out if we need to. But it says, based on the graph, how many relative extrema does the graph have? Give a reason for your answer. So if this is the derivative, what am I looking for relative max or mins? Remember, I'm looking for where h prime of x changes sign, which means crosses the x-axis, right? So looking at my graph, it only crosses one time. Do you agree with that? So, gosh, I have too many buttons to push. Or crosses x-axis. So the answer is, how many relative extrema? Only one relative extrema, because h prime of x crosses x-axis only one time. Look at part 2. It says, based on the graph of h prime of x, how many points of inflection do the graph have? Points of inflection, if I'm looking at the derivative, points of inflection show up as relative max or mins. So looking at my graph, I know I can't really see this. I can change my window a little bit if you want. let's make that go down to -18 maybe. How many times does this change sign here from positive to negative? So it looks to me like here it's a minimum, then we have a maximum, then we have another minimum, and then increasing to decreasing. There is kind of one like right here, right? Increasing. No, I don't think so. Do you think that's increasing the whole time? Oh, that's tough. I think it's increasing. 1, 2, 3, 4, 5. Because this is like increasing the whole time. It changes concavity there, but it's increasing. So inflection points are relative max or min on h prime of x. So 5 inflection points, because there are 5 relative max or mins between that. Number 3 says, find the equation of the second derivative and graph it on your calculator. Explain why the graph confirms your response to question number 2 above. Okay, so let's take the second derivative now. So 2x, the derivative is just 2. This is going to be the product rule. So minus the derivative of x is 1, and then times sine of 2x. Minus x, because I'm going to leave that alone even though it's plus, but it's minus x. The derivative of sine of 2x is cosine of 2x times the derivative of the inside, which is 2. So I'm actually just going to make that minus 2x. And then I'm going to graph that and see what I get here. So 2 minus sine of 2x. 2 minus sine of 2x minus 2x cosine of 2x. Was that right? Let me check. 2 minus sine of 2x minus 2x cosine of 2x. And then how does this confirm? Whoa, that's a crazy second derivative, isn't it? Everywhere that I said there was a max or a min, I think I did something wrong. 2 minus sine of 2x minus sine of 2x minus 2x cosine of 2x. Oh, I think, here we go. I think I did a negative instead of a minus. My answer did not confirm. That's why I had to fix this. This should say minus, and I think I did a negative, and that's going to change everything. Okay. So if this was true, if these are my max and mins here, then my second derivative should cross the x-axis 5 times. So I have 1, 2, 3, 4, 5. And so that's why it confirms it. So when it didn't confirm it, I was a little stressed for a minute. H double prime of x crosses x-axis 5 times. And that's how many total inflection points there are, right? When the second derivative crosses x-axis. And so kind of making that connection, that's the next step that we're making on here. Already at 9 minutes. Okay, so this says, based on the relationships between a function and its first and second derivative, complete the following statements, comparing f and f prime. So we're going to do some of these, and then I'm probably going to stop and let us finish these in class. But if f of x is increasing, what do I know about f prime of x? Then I know f prime of x is greater than 0. Yes? If f of x, the original function, is decreasing, what do I know about the first derivative? It's less than 0. It's negative. And when f of x has a relative max or min, what do I know about the first derivative? Well, it equals 0, but more importantly, it changes sign, right? It crosses the x-axis. So I'm going to put changes sign, like positive to negative or negative to positive. When f of x has a point of inflection, this is kind of the new part. What do I know about the first derivative? Points of inflections are relative max or mins on the first derivative. Has a relative max or min, maybe I should say. What do I know when my graph is concave up about the second derivative? If my graph is concave up, I know the second derivative is greater than 0. If my graph is concave down, what do I know? The second derivative is less than 0. And if my graph has a point of inflection, then my second derivative changes sign. Positive to negative or negative to positive. What do I know if my derivative is increasing? If the derivative is increasing, what does that tell me about the second derivative? Well, it tells me that the second derivative is positive because it affects that the same as this first derivative affects the original function. And if the first derivative is decreasing, what do I know about the second derivative? It's negative. And if my first derivative has a relative max or min, what do I know about the second derivative? That is a point of inflection, right? It has a point of inflection because it's where the second derivative is changing sign. And if my first derivative has a point of inflection, what do I know about the second derivative? That one's kind of tough. If the first derivative has a point of inflection, then the second derivative now has a relative max or min. So I have 5 left here. I think that you should be able to do some of these because it's kind of just going the other way now. Giving this information about the first or second derivative, what can you tell about the function or the first derivative? So see if you can finish those. We'll start here in class, and then we're going to work on this little activity in class.